So today we will look into a few more concepts, okay, which is nothing but called your edge triggered flip-flops. Okay. Fine. So these were the things that was discussed yesterday, the timing diagram, okay, and what is zero sketching and one sketching, okay. Ultimately the values are maintained and then passed on to the slave, right, from the master to the slave. So can you tell me which is better, JK or SR flip-flop? Master slave combination of JK or master slave, which is better, JK or SR? So minus dB will be showing under the ground level. So be careful by drawing your output waveform. Minus dB means under the reference or under the x-axis. Yeah, can I have a response? Which means that your output sine wave will creep into. Can I have a response? Which flip-flop is better? Now ensure that the site is also VM. Ensure that this is also VM. You can just.
Sir, JK, master slave JK.
Master slave JK. Can you tell me why? Good. The answer is correct. Why?
So because there is a feedback system and moreover there is a memory dependence facility. So every time we have to go for the next value, the previous also has to be considered.
Not only that, the main thing is during 1-1. Okay, whenever our inputs are 1-1, in SR, that was giving us an invalid output, right? So in this case, it's not giving us a junk value, but then it's giving us some value, which is actually the complement of memory, right? So that's the advantage of having a JK flip-flop, right? So we will continue our discussion with edge triggered flip-flops. What is edge? As I've told you, it has positive edge and a negative edge. So when I say positive edge triggered, then it's moving from a lower value to a higher value, okay. And when I say negative edge, it's moving from a higher to a lower value. The basic master slave flip-flops, okay, master is enabled during the entire period when control is 1, okay. This can result in zeros and 1 catching, which we saw previously. To avoid this, signals on information lines are restricted from changing during the time from master is enabled, okay. So that's the reason we are actually using this edge triggered flip-flops. So we even saw these operations, okay, wherein we saw that this is our S bar R bar latch, and we even saw exclusively as to if these datas are given, okay, if these values are given, what is going to be our output, right? So I think these concepts are clear with all of you, and the same thing we have summarized here with the help of truth table, okay. And this was the observed timing diagram, okay. So now we will look at something called negative edge triggered. So in this negative edge triggered, as you can see the symbols here, it is the arrow is pointing down, which means that it is negative edge triggered. So action will happen only during the falling edge of the clock cycle or the control bit, okay. And as you can see that the truth table also should be the same, okay. 0 1 1 0 q q bar q q bar, okay. 0 1 1 0 q q bar q q. So the inputs will remain the same, the outputs will remain the same, just that it is reacting to a negative clock cycle. So the symbol is given here, D flip flop q q bar, okay. Then you have clock, okay, q. If just only q is there, then you can see a bubble, right? Okay. So a falling edge, which means from high to low transition of clock signal, is used to sample the D input line, okay. So as you can see that we are using our D flip-flop. Simply place the inverter at the control input of the flip-flop. So if we want to negate, okay, so a high value a high value, then an inverter, so that will work for a falling edge. So that is how you can actually work with your negative edge. Okay, any doubts here, students? Any doubts as to how negative edge triggered flip-flop works?
Sir, how will it get triggered in this negative edge?
Negative edge, same like how it was triggering in positive, right?
Okay.
So in positive, let me show you. In positive, whenever it's positive, then it's going to look for the values of D, and D values are cost to Q. Is this point clear? Right. Now, what is going to happen is, instead of it happening in this rising edge, okay, it will actually happen in the falling edge. Okay. So at the falling edge, it will look what values, and those values will be passed to Q. So how do I enable this falling edge? I will just use an inverter. Is that clear?
Yes, sir.
Instead of high signal,
Yes.
I will be considering low signal. How will I do that? I will just invert my options. How will I invert my options? Using an inverter. That's it.
Yes, sir. Thank you,
Okay.
sir.
Fine. Welcome. So these are your positive triggered JK flip-flop. Now remember, okay, it's important for you to note, okay, these values, okay, or this truth table. Okay, anyway, I will be sharing this with all of you. Okay, but then it's important for you to make a note of the flip-flops, as I told you, JK, SR, T, D. These four are very much important. SR we will not be using much. Okay, but then you can just have it for your reference. SR, JK, T, D. So these four flip-flops, and as to how it's going to function. Now you might be wondering as to how we actually got this circuit. Okay, as of now you wouldn't understand as to how we got this circuit. We will be solving few problems, okay, and then you will know how I have actually converted a D flip-flop to a JK flip-flop. Okay, so this is actually a conversion that has happened. I'm using D flip-flop in order to get JK flip-flop. So how is that done? I will show you when we solve some problems. Okay, and this is your D flip-flop. Okay, and I am making use of D flip-flop in order to get the function of T flip-flop. Okay, so this also we will see, and we will look at the characteristic equations. So before we actually look into these concepts, okay, what I will do is I will share some information wherein you will be able to understand as to how exactly we are going about with this process. Okay, so I want you to pay attention, okay, very closely, so that these concepts are understood. This is a very important concept. You might get problems based on this in your internals and even in your exams. Okay, so this is your SR flip-flop. Okay, whenever the clock is 0, okay, S and R, whatever values you give, those are not considered at all. So which means the output is whatever is in the memory. When my clock is enabled, all these are when my clock is enabled. When it is 0, 0, it is Qn. This is just the truth table of your SR flip-flop. So when it is 0, 0, it's Qn. When it is 0, 1, okay, it is 0. When it is 1, 0, it is 1. And when it is 1, 1, invalid. So because of this invalid state, as I was mentioning you, because of this invalid state, okay, we are not at all considering our SR flip-flop. Instead, we give more importance to JK flip-flop. Okay, nevertheless, what we will do here is, we will just look into the flip-flop, and we will try and understand as to how exactly it is done. So this is my characteristic table. Okay, so before that, there are some rules that needs to be followed. Characteristic table, excitation table. Okay, so there are some rules for conversions. As I told you, we can use JK flip-flop. JK flip-flop can be implemented using D flip-flop. So how do we do it? First, we will understand what is a characteristic table, what is an excitation table. Okay, Fine. Now that you know this is your truth table, okay, this is your SR flip-flop truth table. Now we will come to something called characteristic table. So this is your second step. So what is this characteristic table? It is nothing but what I'm going to do is I'm going to have a present input which is Qn, and my next input is going to be Qn plus 1. In our previous sessions, we have seen it as Q plus. Q plus is the next input. Okay, so here we are looking at Qn plus 1. So Qn is the present input, Qn plus 1 is the next input. Now do not worry about why is it placed here. I will come back to that. Okay, just make sure that you have Q, okay, SR. So this is a 3-bit combination. So if it's a 3-bit combination, I'll be having from 000 to 111. So these combinations are done. Now what I'm going to do is I'm going to apply, or I am going to make use of my truth table now. So using my truth table, I am going to develop my characteristic table. Now in my truth table, when it is 0 0, okay, what is the value? What is my output? Can someone unmute and tell me when SR is 0 0, what is my output?
Sir, it is 0.
You're sure it is 0?
Yes, sir, because Qn is also 0 and S is 0 and R is also 0.
No, your answer is correct, but the explanation you gave is wrong. Now when S...
So the past value of the clock.
Yes. So when S and R both are 0, Qn, whatever is Qn, that is going to be my output. This should be your answer. Understood? So now you concentrate only here. 0 0. What is Qn? 0. So this 0 is going to come here. So which means you have to compare your truth table. Okay, this truth table you have to compare, and also you have to have a logical line here. Okay, and you will be considering only S and R, only S and R, only S and R. Okay, now let us take the next case, 0 1. Okay, so what is 0 1 here? 0 1 is what output I'm getting?
0
right? So in this case, what happened when it was 0 0? When it was 0 0, what?
Sir, I have one doubt here, sir. Sir, in step 1, the output is Qn plus 1, but in step 2, we have to consider Qn or Qn plus 1.
See, your doubt is Qn plus 1, right? But here what
Yes.
have I written? Qn, right? So in order
Yes, sir.
to remove that confusion in your mind, I have put that Qn here.
Okay.
Understood? So that's why I was telling,
Yes.
do not worry about the order as to how I have written. You will come to know once I finish the explanation. Okay.
Okay, sir.
Now we will look at this table and we will look at characteristic table. Okay. So only our concentration is on this table and characteristic table. Now let us take the first value for the benefit of everyone. Now I have 0 0 here, right? So when I have 0 0, what is my output? What am I supposed to get? Qn, isn't it? Are you all with me?
Yes, sir.
Yeah.
Yes, sir.
So what is Qn here for 0 0 combination?
Sir, it is 0.
0, exactly. So what will happen if it is 0? That 0 will come here. Okay. Now
Yes, sir.
let us go to the next case. Next case is what? 0 1. So for my 0 1, directly I'm getting a binary value here. So I don't have to check for what is the value of Qn, isn't it? So since my 0 1 is already 0, that 0 I'm putting it here. Okay. Now let us go to the next case. Now the last topic. Let me just erase it. So it'll be easy for you. Okay. Now let us go with the next case. So next case, what is my 1 0 here? 1 0. 1 0, what should I get?
It is 1.
1.
Qn plus 1.
Right? So that 1 I am bringing it here. Fine. Now here in the next case, it is 1 1. So it is invalid. Invalid means what I will consider? I don't know to consider 0, or I don't know if I have to consider 1. So instead what I will do, I will put it as don't care. So for my benefit, I will make it 0 or I will make it 1. Right? So again, we are getting back to 0, 0 here. So if it is 0, 0, whatever is in Qn will be my output. So Qn is what here? 1. Isn't it? So 1 is going to come here. Any doubts, students? Please ask me if any doubts.
Sir, in the next step, it is the Qn plus 1 is 0, but the Qn is 1.
Which step?
So the last one.
The next combination?
Yes, sir.
0, 1. 0, 1 means what? You have here, no? 0, 1 means? 0, 1 means what?
So 0, 1 means the
0, right?
Yes, sir. Yes, sir, it is 0 in the first step.
That 0 is coming here.
Okay.
Simple, right? So you are looking at Qn only if you have 0, 0. Right? You're looking at Qn only if you have 0, 0 combination. Right? See, where do I have Qn here? I have Qn only when the inputs are invalid. Of course, yes, of course, we are not going to take a clock 0. We are always going to give clock. So which means you can nullify the first step. So we are looking at Qn only for the combination of 0, 0. Understood? Rest all is straightforward answer. 0, 1 is 0, 1, 0 is 1. So this is how I develop my characteristic table. So let us take one more case here. 1, 0. So 1, 0 means what? Should I look at Qn? Should I look at Qn or not for 1, 0?
Yes, sir. For 1, 0, you have to look at.
Why should I look at Qn?
Sir,
No, sir, only for 0, 0.
We will see the 1, 0, na?
So only for 0, 0 I am seeing, that's all. For 1, 0, I have a direct answer here.
Yes, sir.
Right, 1, 0 is 1. That's it. I'm not looking at what is in my memory. So 1, 0, I'm getting 1. Similarly, 1, 1. 1, 1 is what? Invalid. So 1, 1, invalid. Right? So this is my characteristic table. So in order to get your characteristic table, you should know how is your truth table. So the next level of truth table is characteristic table. Okay, so you can put S, R, Qn plus 1. So Qn plus 1 is actually prediction as to what will happen for this combination, what I'm going to get in the next output, the next state output. Okay, so once we have this, okay, it's very easy for us to put this into the K map. Okay, so 0, 0, okay, 1, don't care. So all these values are pushed into my K map. Okay, all these values are put up in my K map. Okay, and once I have my K map, I will just look for ones, group the ones, and accordingly I will have my equation for Qn plus 1. This equation is called your characteristic equation. Is it clear, students? Is it clear?
Yes, sir.
So, yeah, tell me.
No, sir.
It's fine, no?
Yes, sir.
Okay, so we are looking at truth table first. Once I have the truth table, then I'm going with characteristic table. To build the characteristic table, I take the help of truth table. Why do I need to take the help of truth table? Because I do not know what is the value of Qn. So Qn, in order to make it very easy for me, what I will do is I will not put it very far. I will put it next to me here only. Okay, I'll put it next to me here only. So these values I can just map it. I can just map it to my Qn plus 1. If I have 1, 0, it's a direct 1. If I have 0, 1, it's a direct 0. If I have 1, 1, then I will give a don't care case. Once I have developed the equations for Qn plus 1, what is my next step? I will just put them into my K-map. And as you all know, K-map is going to have grouping. Maximum grouping is good. So here I'm looking at 4 ones, How am I getting 4 ones? Don't care. I'm converting them to 1, assuming that it is 1. So I make a group of 4 ones. So once I have a group of 4 ones, I'm getting S. How am I getting S? 0, 1 gets nullified here, right? And then I have 1, 1, 1, 0. Okay. So 1, 0 gets nullified here. I'm having only 1, and this 1 is nothing but my S. So S is here. So this S, I'm bringing it down here. Similarly, I am getting a group of 2 ones here. Okay. So this will be my Qn because it's across 1, right? Qn is there. And then I have my 0, 0 and 1, 0. Okay. So my 0 and 1 gets cancelled. The only thing that remains is my R, low R, right? So that low R is coming here as my R bar. Any doubts here, students?
No, sir.
Okay, fine. Now that we know how to develop a characteristic table, we know how to develop a characteristic equation. Now let us still complex our thinking. Okay, we will go into another table called excitation table. Okay, now here excitation table, I can call this as a rearrangement of your characteristic table. Why am I calling it as a rearrangement is because you will understand now. Qn I will retain as it is. Qn plus 1 I will bring here. Okay, so present state, next state is going to be my inputs. My outputs are going to be SR. Okay, now here you need a lot of concentration. Okay, I want you all to concentrate. Now since I have 2 bits here, Qn and Qn plus 1, what is going to be my combination? 0, 0, 0, 1, 1, 0, 1, 1. I'm going to take all the combinations here, right? Fine. Now let us see, I have to check for Qn being 0 and Qn plus 1 also being 0. Okay, students, I need your concentration. So here I'm looking for Qn is 0. Okay, this case, and my Qn plus 1 is also 0. Okay. Do I have another combination like this where I have Qn and Qn plus 1 both 0? Do I have another
In the
combination?
step 2.
Step
2, sir.
Exactly. So Qn is also 0 here. Qn plus 1 is also 0 here. Fine. Now I have to look at what is my S and R. Okay. Now you must put a logical box in your mind. Okay. Try to put a logical box in your mind and restrict your thinking, okay, only to this box. Now here, see the values of S and R. Compare the values of S and R. Don't you think S is 0 in the first step and S is 0 at the second step? So directly I can just write S is equal to 0.
Yes, sir.
Compare the value of R. R is 0 and R is 1. So which means I can write don't care. Right? So which means
Yes, sir.
first case over, second case over. Now let us go to the next case. Next case, I have to search for Qn being 0 and Qn plus 1 being 1. Okay, so we have one situation here. Okay, we have Qn 0. Okay, and then Qn plus 1 is 1. Right? Any other combination like that? Any other combination? No, right? So this is my only combination. So what I will do directly, I will bring those values down. S is 1, R is 0. Any doubts here?
No, sir.
No. Okay. Now let us go with 1, 0. Okay. So I will be looking at 1 here. So 1 is here. No, I cannot take this because this is 1, 1 case. Okay. 1, 1 case. So I cannot take that. I'll have to look at 1. 1 is here. 0 is here. Any other combination 1, 0? only qn 1 and only qn plus 1 0. Any other combination like that?
No, sir.
Nothing, right? So directly I will bring down those values here. 0 and 1. Okay. Now let us go to the next case, which is 1 1. Okay. Now in this 1 1, what is going to happen? In 1 1 case, qn I'm looking at 1, output also qn plus 1 also should be 1, and which is the other case? Other case is here 1 and 1. Yes. So now what we have to do? We have to look at two boxes. We have to look at this box. Okay. And we have to look at this box. Now I have the value of qn 1 1, and then I have the value of qn plus 1, which is 1 1. So I have to concentrate now on only these two, 0 0 and 1 0. Okay. So now if you can see your R value, is it changing? R value? Is R value changing?
No, sir.
No. So which means I can just put it as 0. Okay. Now you see the value of S. Is it changing?
Yes, sir.
Yes. Okay. So that 0 1, since it's changing, I will put it as don't care. So this is your excitation table. Any doubts?
Sir, just wanted to know, sir, like why are the tables called characteristic and excitation tables?
Characteristic is because it will characterize your flip-flop, which means I am trying to draw what kind of character, what kind of output it's going to give me now, and what kind of output it's going to give me next. Okay. Now excitation table is what inputs will actually give me, okay, what kind of values will actually give me 0 0, or if my outputs are 0 0, what kind of inputs I should give. Maybe you're targeting at outputs, say only 1 1. You want outputs to be only 1 1. So what kind of input combination you have to give? So you can give S anything here, in this case 1 or 0. But if your R is 0, then your outputs are going to be 1 and 1. So how are you exciting your circuit in order to get these values as your output? So it's called an excitation table. Understood?
Okay, sir.
Okay. So once we have these values here, wherever you have S is equal to 1, okay, so that is going to be your Qn, okay, Qn bar and Qn plus 1. Of course, don't worry about this, okay, it's incorrectly written. And wherever you have here 1, okay, that value is taken. Fine. We do not need an excitation table equation, okay, or we do not need an excitation equation. We just need an excitation table. And most importantly, we will also need a characteristic equation. So I hope you have understood now how to get your characteristic table and your excitation table. Any doubts here, students? So how are we taking truth table? How do we know the truth table? SR flip-flop will have
sir,
invalid.
the SR flip, sir, in the SR flip-flop, the step 1, sir, we are getting the output from the diagram, right?
From the, yes, from the diagram.
Okay.
Yeah.
Yes.
So that is summarized here. Truth table is nothing but a combination of input and output. So if you can compare, what we had studied, your SR flip-flop, right? So from the diagram, you're getting these values.
So
That
sir,
is correct.
in step one, if we get any questions for SR flip flop, the step one won't get changed, right?
No, not at all. SR flip flop will always remain the same. Okay.
Okay.
Now tell me,
Yes,
what is your USN?
Sir, 1NH19EC084.
084. There can be
Yes,
another person called Nirmit Verma. Okay. But there
sir,
cannot
I am
be,
Nirmit Verma.
I know. But there cannot be another person with the same USN, which is 84. Right?
Okay, yes,
Okay.
yes, sir.
So even if there is another person with the same name, he is going to get a different USN, which is 85. Okay. So treat
Okay,
this truth table as an USN. So it is very unique
okay,
to a particular flip flop. Understood?
okay. Yes, sir.
Okay. So
Yes,
this
sir.
is about your SR flip flop. So we are writing the truth table. Once we have the truth table, we are taking characteristic. In order to take characteristic, we are actually looking at, we are taking the help of truth table, and from there we are finding out what is the next output or Q plus values. Once we have those values, put them into K-map, or you can even do MEV method, or any other method you can use, and come out with an equation, Boolean equation, and that becomes your characteristic equation. So once you have that, once you develop your characteristic table, then it is easy for you to develop a excitation table. Excitation table is nothing but what outputs I'm going to get for what input combinations. Okay, so that is my excitation table. So the same thing applies for your other flip-flops, which is your D flip-flop. Clock 0, of course we will not consider this. When clock is 1, whatever is D, the same thing you will get as your output. 0 as your input, same thing as your output. 0, 1 as your input, the same thing will be at your output, which is 1, but at a delayed time. Okay, so if this happens, then it is called a D flip-flop. How do I get a characteristic equation? I will get a 2-bit combination here. Always remember, one more clue I'll give you. SR, okay, I have 2 inputs. So here characteristic equation will be the next level. One more input will get added. So 2 inputs are getting 3 inputs here. Okay, so here D is only 1 input. Okay, so I'll be adding one more here, which is nothing but your Qn. So input plus output, keep that in mind. Characteristic equation towards your left hand side is going to be your input and output. So Qn and D. So I have 2 bits here. Once I have 2 bits, you all know it's going to be 0, 0, 0, 1, 1, 0, 1, 1, right? So once I have this, I'm going to compare. If it is 0, okay, what is going to happen? Whatever is in Qn, the same value is going to come here. If it is if it is 0, sorry, if it is 0, I'm going to get a 0. If it is 1, I'm going to get a 1. So here there is no effect of Qn unless there is a clock disabled. So you can see that D is equal to Qn, isn't it? Yes or no? Are these values same? 0, 1, 0, 1, 0, 1, 0, 1, are they same? Students, respond.
Yes, sir.
They're
It is
same,
same.
right? So what I can do, I can say that my Qn plus 1 is equal to D. So these two are equal to each other. So that is my characteristic equation. So D flip-flop is your simplest flip-flop, and with a simple characteristic equation. You don't have to put a K-map for this, and you don't have to get into the reduction methods. Okay, you can just see that wherever it's there, the same thing is available. Okay, so you can just say that it is Qn plus 1 is equal to D. So that is done. So once you have that, the next thing is your excitation table. So which means what is going to be towards my left hand side? Can someone tell me? Excitation table towards my left hand side, what is
Sir,
going to be?
Qn and Qn plus 1.
Yes, and towards my right hand side, what is going to be?
Sir, Qn and
Right hand side. You're there? Right hand side, what are we going to have? We're going to have the input, right?
D, sir.
Yes. we're going to have the input. What inputs I'm going to give so that I get particular outputs, right? So which means your excitation table is a rearrangement of your characteristic table. Okay, see, don't get confused. Okay, see, qn is here. Okay, qn plus 1 is here. Only thing is you are bringing your d this side. Okay, so once I have two bits, I'm going to go with my normal combination 0 0 0 1 1 0 1. Okay, and since your values are the same, qn plus 1 is equal to d, so what is going to happen? The same thing is going to continue 0 1 0 1. Okay, so this is the simplest form of your excitation table. Any doubts here,
Sir, one
students?
doubt.
Tell me.
Sir. Sir, in the characteristic table, sir, I had one doubt. Like, can you just explain how did you get the QN values like 0 0 1 1?
In characteristic. In
Yes,
which
sir.
one? Characteristic or excitation?
The characteristic.
Characteristic. Okay, this is nothing science. Simple. See, I'm treating this one as one input. I'm treating this one as one more input. So 2-bit input, 2 raised to 2. That's it. 2 raised to 2 is what?
Okay. So the QN is basically like an imaginary input.
That's all. For you all to make it simple,
Okay.
I have given it as QN. Okay.
Oh,
I can
okay,
even give here something else. AB also I can give. Okay. To make it simple for you, I've given as QN so that it becomes easy for you.
Yes, sir.
Okay. So this is just a normal 2-bit combination. And how am I getting these outputs? These outputs I'm getting based on what? Based on what? I'm getting these outputs
truth
based
table.
on, yes, you have to refer to your truth table. So once you have the truth table, you can develop characteristic. Once you have characteristic, you can develop your excitation. Is that clear?
Yes, sir.
Yes. You're all able to follow, right?
Yes, sir.
Okay. How is it? Interesting?
Yes, sir.
If
Yes, sir. It is.
Yes, if you're sleepy, you will not understand anything. You need full concentration for this. Then only it's going to be interesting. If you understand, then only you can say that it is interesting. If you don't understand, then it's not interesting for you. Right? Okay. Now let us move on to the next one, which is your JK flip-flop. Same concept. Okay. As you all know, you have seen the circuit JK flip-flop, right? So from the circuit, I'm getting my truth table. One thing that you can notice when it is 0 0, okay, that's when I'm going to have your memory state. Okay, and when I have 0 1, it's going to follow my J, which is 0 1 0 1. And unlike your SR flip-flop for 1, I'm getting a negated value of whatever was there previously in my QN. Okay, so this is my truth table. Fine. So now next we will get into something called characteristic table. Okay, so for characteristic table, what am I going to do? I'm going to have, as I told you, JK is what, 2 inputs. So I'm going to add one more to it. So it becomes my 3 input. So QN, so what is my 3-bit combination? 2 raised to 3. So which means I'm going to have 8 combinations, isn't it? So 0, 1, 2, 3, 4, 5, 6, 7. So I'm going to have 8 combinations. Once I have these, then I'm going to start computing as to what is my QN plus 1. Okay, so here I'm going to check, okay, for 0 1. So whenever it is 0 1, it is 0. So straightly I will just put it 0 0 0 0. It's going to check what is in QN. So what was in QN here? What was in QN?
0
0. So the same 0 comes here. Okay, so I think you have understood the characteristic table, right? Can I proceed?
Yes, sir.
Can I proceed? Yeah. So once you have these values of QN plus 1, Okay, map them into your K-map, and you can group them, and accordingly you can write your equation. So once we have the characteristic table, towards my left side I'm going to have my outputs, towards my right side I'm going to have my inputs, which are JK. And at the moment this Qn and Qn plus 1 are acting as my inputs temporarily. I'm considering them as inputs. So 0 0 0 1 1 0 1 1 is going to be my combinations for 2 raised to 2, and I'm going to check wherever Qn is 0 and wherever Qn plus 1 is 0. Okay, for example, here and here and here and here. So in this case my J is 0 and my K is changing from 0 to 1. So in that case, what am I going to do? I am actually going to put this section as my don't care. Okay, so similarly I get all the other values for 0 0 0 1 1 0 1 1. I'm going to get all the values, right? Fine. So for T flip-flop, you have to know what is your truth table. Okay, ultimately when it is 0, okay, whenever it is 0 it will have whatever is in the memory. Okay, whenever it is 1, whatever value was there previously, that will be negated. This is the property of your toggle flip-flop or T flip-flop. So T, whenever T is enabled or whenever T is high, the toggling happens. Why is it called toggling? Because it's going to change from Qn to Qn bar. Okay, fine. So this is our truth table, characteristic table. I'm going to see I have only T as my input. I'm going to add Qn to it. So 0 0 0 1 1 0 1 1, and now I'm going to compare. Whenever it is 0, I'm going to put what am I going to put whenever it is 0? Whenever it is 0, what? This combination, right? This combination. So whenever it is 0, I'm going to put whatever is in Qn. So 0, what is in Qn? 0 will come here. So whenever it is 1, what is going to happen? Toggling has to happen. So toggling with what? Toggling with what? Students, you're all there?
The output.
Yes, exactly. So I have a 1 here. So if I have a 1, it should be Qn bar. So what is my Qn here? 0. 0 bar is what? 1. Okay. Whenever it is 0, then Qn just directly straightly comes here. Whenever it is 1, okay, it is toggled to the other value. Any doubts here? Any doubts as to how we got this characteristic table?
Okay.
Okay, fine. So now that we know, okay, directly you can write the equation. Okay, wherever you have high value, you have Qn bar and T. Okay, then you have um, Qn and T. Okay, so this one I can represent using my XOR gate. Right, so Qn is XORed with T. Fine, so this is going to be my characteristic equation. And now if I have to look for my excitation table, what is going to be towards my left hand side? Can someone unmute and tell me? Left hand side, what
Sir,
am I
it
going
will be T. T.
to? Okay, and towards my right hand side, are you sure it's going to be T? Towards
Sir,
left
in
hand
right
side?
hand side it will be T.
Okay.
And in the
The
left hand
left
side it
side
will
will
be
be Qn
Qn
and
and
Qn plus
Qn
1.
plus 1.
Okay.
Yes, sir.
Good. So we are going to have the same thing. T is going to come here and Qn plus 1 is going to come here. I have 2 bits, 0 0 0 1 1 0 1 1 is going to come. Okay, and now I'm going to check for 0 0 0 0 when Qn is 0 and Qn plus 1 is 0, what is T? T is 0. So similarly, when it is 0 and 1, what is T? That value will come. When it is 1 and 0, what is T? Okay, that value will come. when it is 1 and 1, 0 is the value of t, so 0 will come here. Simple, right? Only thing, you need a lot of concentration. You should not mess up with what are going to be the inputs and what are going to be the outputs. Very simple. Truth table, know the truth table, know the property of your flip-flop firstly, then you'll get the truth table. Once you have the truth table, then you can automatically take the inputs plus 1. If it is 2 bits, it's going to become 3 bits. Put the combination of 3 bits from 000 to 111. Once you have those values towards your left hand side, then look for qn plus 1. So how will you look for qn plus 1? With the help of your truth table. Once you have filled qn plus 1, put or load your k-map. Once your k-map is loaded, you will get a fine equation, and that is called your characteristic equation. Next, work on your excitation table. How will you work on it? Your outputs are going to be towards your left hand side, and temporarily those are going to be my inputs, and then towards your right hand side is going to be my output, but temporarily it is the input. So accordingly, I'm going to take the help of characteristic table, and I'm going to get the excitation table. Fine. Is it all clear, students?
Yes, sir.
Yeah. Okay. So now we will do something called flip-flop conversions. So before flip-flop conversions, what I will do is I will share another thing with you. Let's get back to the slideshow which I was showing you all. Now you will be able to understand what is a characteristic equation, right? So we saw this, till here we all saw just a moment. We have seen this positive edge triggered. Okay, so after this positive edge triggered, you will be seeing characteristic equation. I don't have to explain this because we have seen that in practicals, isn't it? So characteristic table, it shows the next state table, shows the value of next state of the flip-flop for each combination of values present for the flip-flops and their information lines. The algebraic description of this is going to be your characteristic equation, and this is obtained by constructing the k-map, and you can load those values into the k-map, right? So these are your tables that you will have to know for your SR, JK flip-flops, and you have D flip-flops, T flip-flops. Okay, these are your tables. Okay, and this is your next state table. Okay, so here what they have done is they have taken Q here and Q plus here, but instead I have taken Q towards this side, making it the most significant bit. So anyhow is fine, don't worry. Okay, don't worry, it's all the same. So I'm loading those values in the k-map. Once it's loaded, I get a fine equation. Okay, so these are your equations for SR, JK, D, T. So in your exam, I'm going to ask, how is T flip-flop, or derive the characteristic equation and express or represent its excitation table. So you will have to draw the flip-flop structure, the truth table, characteristic table, k-map, load k-map, put the characteristic equation. From the characteristic equation, of course, you can summarize that, and then you can get an excitation table using your characteristic table. Okay, fine. So another thing here, that is actually left out is your D flip-flop using CMOS, pass gates, and inverters. Okay, so this is going to be your standard circuit. Okay, just like how we have circuits for your SR flip-flop and JK flip-flops and T and D. Okay, so this is going to be your standard circuit where we will be using D flip-flop, okay, which will be represented in the form of CMOS, pass gates, and inverters. Okay, so we will look at this deeply probably in the next class. Now I want to actually concentrate on how to get the conversions. Okay, now that we have seen your flip-flops, characteristic table. Okay, so we will get into something called conversions. Okay, right. So we will now convert from one flip-flop to another flip-flop. So these are some of the steps. Okay, you will have to remember these steps as to how to get these conversions done. I will actually send in your attendance. Do not worry about it. So first, let us concentrate on getting this flip-flop conversions understood. Okay. So the first step is identify what kind of flip-flop is available and to what flip-flop I need to convert. Okay, that is my first step. Are you all with me?
Yes, sir.
Okay, so we are going to have problems based on these information that I'm going to share. Okay, so it's going to be the flip-flop conversion. I can tell convert, okay, convert JK flip-flop to D flip-flop using your flip-flop conversion technique. Okay, so that is going to be the question. So for your answer, these are going to be your steps. How you're going to solve it, we'll see one by one. Identify available and required flip-flops. So you have to know what flip-flop is available and to what flip-flop I need to convert. Okay, so that is your first step. The second step is make characteristic table for required flip-flop. Okay, so what I have to do, I have to make a characteristic table for my required flip-flop. Keep in mind characteristic required, excitation for available. Okay, so you should be making note of these important points, okay, because you may tend to forget. So characteristic table for which one? Required flip-flop. And then your excitation for available flip-flop. Most of the students that I have seen, okay, they get confused with this and they actually put excitation for required and they put characteristic for available. So ultimately in logic design, if one goes that side and if zero comes this side, you will totally lose your answer, right? Leave about 1 and 0. Just if a 1 becomes 0, okay, your total answer is going to be wrong. So keep in mind required flip-flop, you're going to put characteristic table. For available flip-flop, you're going to use the excitation table. So which means to know the excitation table, you should know its truth table, you should know its characteristic table, and then the final third step is your excitation table, right? Okay, fine. So write the Boolean expression for available flip-flop and you can draw the circuit. So according to me, the main steps here is 2 and 3. These are the main steps. So if you are very keen with 2 and 3, then the rest is just a piece of cake. Okay, now let us continue. So the first one, what I need to do, I need to convert, okay, JK to D flip-flop and using my flip-flop conversion. So once you see this question, okay, what do you understand? Which is available? Which flip-flop is available? They're telling me to convert JK to D. So which flip-flop is available? Students, you're listening? Okay, fine. Thank you for the replies. I've got it. Yeah. So your available flip-flop is JK. Okay, and they are telling me to convert to D. So this becomes my required flip-flop. So the first step is identifying which is available and which is required. So available flip-flop is JK. So using JK, I have to make D flip-flop. Okay, that is my problem now. So in the first step, I have identified as to what is my available flip-flop, and in the next one, we are actually checking which is our required flip-flop. So first step is solved. In the next step, what we need to do, for whom do we have to make a characteristic, and for which flip-flop do we have to make excitation? Can someone unmute and respond? Characteristic is for?
Sir, JK, we have to find the characteristics and
Correct.
excitation.
So your available flip-flop, is it characteristic or excitation? Available.
Sir, characteristics.
Are you sure?
So available is excitation.
Available is excitation. Required is characteristic. Okay. So required is characteristic. Available is excitation. Do not get confused. Please write down. All of you write down. Required, characteristic. Available, excitation. Just make note of this. This is going to save you. Okay, fine. So what we will do now is, we will take the values of D. So this is required. So I'm going to have a characteristic table of it. Okay. So how do I have a characteristic table? I'm going to add one input to it. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. This is my characteristic table. And for the available, I will be using the excitation table. Now here, if you can observe, what I have done here is, I have actually written the excitation table here in 3. Okay. The excitation table is in 3. And in order to make my analysis simple, okay, if you can observe 0, 0, 0, 1, 1, 0, 1, 1, then here also you have 0, 0, 0, 1, 1, 0, 1, 1. So what am I going to do? I will just combine them. Okay, I will just combine them, and I will use another table, or I will combine the values to the same table. Just observe it.
Sir, can we continue in next class?
Okay, just this problem, and then we will stop there. Okay, it's a very easy one. Okay, just one problem. So since I have 0, 0, 0, 1, 1, 0, 1, 1 here, okay, and here also I have 0, 0, 0, 1, 1, 0, 1, 1, I am interested in only the values of JK. Okay, so what I will do is, in order to make my truth table simple, I will combine my excitation table here itself. Okay, so how did I get this? This was obtained based on our excitation table of JK flip-flop. How did I get excitation? Based on the characteristic. How did I get the characteristic? Based on the truth table, right? So I am combining, and I am trying to get a single table here. Is that clear, students? Up to this point, is it clear? Up to this point, is it clear? Yes? Are we clear up to this point?
Yes, sir.
Yeah. So now what we have to do, the next one is very simple. Okay. We are going to look where I have 1 for J. Okay. So I am going to load that value into my K map. Okay. So Qn and D is going to be my input. So 1 is here, and then I have my don't care. I'm going to pair it up. So J is equal to D is my equation. Similarly, I will be looking for 1 and don't care. So don't care is there, 1 is there. I will pair them up, and I'm going to get the value K is equal to D bar. Okay. So once I have these values, what I'm going to do is, I'm going to draw the structure. So this is my JK flip-flop, J, K, Q, Q bar. So for J, what is the value given? D. So D is here. For K, what is the value? D bar. So for K, I am using an inverter, and D bar is connected to K. So in this way, what have I done? I have actually converted my JK flip-flop into what? Into a D flip-flop. So this is my JK flip-flop, right? So this JK flip-flop is converted to a D flip-flop. Is that clear, students? Is it simple?
Okay.
Yes? Okay. So the only thing that you have to know here is which is available, what is required, and available excitation, okay, and required characteristic, combine them both, load the values into K-map, you get the equation, and your available, okay, keep in mind, available flip-flop will be here, okay, required will be at the input side. Required will be at the input side, available will be at the the actual flip-flop structure. Okay, so with this, we actually conclude the class, and then we will probably look into another problem maybe sometime later. Okay, so I think by now you would have understood as to how these conversions do happen. Okay, so I'll be just sharing in the link in some time. Okay, and if any doubts, you can always feel free to get back and we can have a discussion on it. Okay, fine, thank you.